So today we will start that module 5. In this module 5, what are the drawbacks we are facing in using the Fourier transform that we will overcome using new transform that is called Z transform. Z transform. So the name came from the scientist name called Jade. So based on this his name, we are named as Z transformation, or we can say Z transform. Now, if you recall that Fourier transform, in Fourier transform we have continuous time Fourier transform and as well as discrete time Fourier transform. Now, what is the drawback among these two? What is the main drawback? We can analyze the energy signals. Energy signals we can analyze, but power signals indirect way we can analyze, not direct way. Indirect way we need to convert into exponential form. Then we can analyze the power signals. If it is a neither energy nor power signals, it is not possible to analyze using Fourier transform. If it is a neither energy nor power signals, we cannot analyze the by using Fourier transform. Similar way, if we consider the stable system we can analyze using Fourier transform, but whereas coming to the unstable systems, we cannot analyze using Fourier transform. That's why that's why to overcome this drawback, that means to analyze this neither energy nor power signal, to analyze the unstable systems, we required one more transformation. For continuous time Fourier transform, we have Laplace transform. For discrete time Fourier transform, we have Z transform. So Laplace transform, anyway, this is related to continuous time Fourier transform extension. We can call it as extension of Fourier transform. But anyway, as per our syllabus, we don't have the Laplace transform. We have Z transform. Z transform is a extension for the discrete time Fourier transform to analyze the neither energy nor power signal and as well as unstable systems. So now we can say that Z transforms Z transforms are used to analyze all types of systems bar signals, all types of signals and all types of systems. So here all types of systems and signals we can analyze, like that we are discussing, right? But here also one drawback is there. What is the drawback? How to, I mean, what type of signals we cannot analyze using jet transform, that we will discuss. But as of now, to overcome the difficulties or to overcome the disadvantages arising from the Fourier transform, we can solve using jet transform. Now, the representation of the Z transform, x of n, Z transform, you can write here Z, or you can write Z transform, no problem, ZT. Z transform is x of Z. X of n, Z transform is a capital X of Z. What is this capital X of Z? X of Z is, I told this is the extension for discrete time Fourier transform. That's what x of z is, summation n equal to minus infinity to infinity x of n into z power minus n into z power minus n. What is this? Z is nothing but r into e to the power of j omega. What is meant by z? Z is nothing but r into e power j omega. So if I write this expansion r into, this will become cos omega plus j sin omega. Anyway, that is not required for us. So now, what is the magnitude of the z? Here it involved two terms. One is magnitude of z, another one is angle of z. Now, if you look at here, r e power j omega, it looks like the polar form. It looks like a polar form. In the polar form, we have the magnitude, or we can say radius of the circle, and what is the angle of the point, where the location. So now the magnitude is r, the angle is omega. So these two are very, very important. First thing in introduction about the jet transform, first we need to understand how to represent the jet transform. Representation. How to represent the jet transform? X of n jet transform is x of z. What is x of z? X of z equal to summation n equal to minus infinity to infinity x of n z power minus n. What is this z? Z is nothing but r e power j omega, where r is the magnitude, omega is the phase angle. Is it clear, all of you, right? Now, first we understand how to represent the jet transform. Second, we need to see that existence condition. Existence condition. Existence condition is nothing but the magnitude of x of z. It should be finite. Magnitude of x of z should be finite. That is the condition, right? Generally we will do. So now we will see here x of n z transform. X of n z transform is x of z. X of n z transform is x of z. What is meant by x of z? X of z is equals to summation n equal to minus infinity to infinity x of n z power minus n. What is meant by z? Summation n equal to minus infinity to infinity x of n. What is meant by z? Z is nothing but r e power j omega. R e power j omega whole power minus n is equals to x of z. Now x of z is equals to summation n equal to minus infinity to infinity x of n into r power minus n into e power minus j omega n. Now, if I want to find the existence condition, what I need to find? I need to find modulus of x of z. What is the modulus of x of z? Summation n equal to minus infinity to infinity modulus of x of n modulus of r power minus n modulus of e power minus j omega n. Now, if you recall, what is the modulus of e power j omega n? E power minus j omega n is nothing but cos omega n minus j sin omega n. What is the magnitude of e power minus j omega n? What is the magnitude? It will become 1. Now, now, what is the magnitude of x of z? X of z is nothing but summation n equal to minus infinity to infinity modulus of x of n into r power minus n, because e power minus j omega n is 1. Now, here, if you look at that, this is the existence condition for the jet transform. Now, the magnitude is depends on x of n is the input signal, no problem, but here what is the another term is there? R is there. So this value depends on the if jet transform, not if, jet transform existence, the existence of jet transform is depends on suitable value of r, suitable value of small r. This is very, very important. What is this small r is nothing but what is meant by this small r is nothing but ROC. That is nothing but region of convergence. Region of convergence. Now that means whether the jet transform is whether the jet transform is exist or not depends on the region of convergence. If there is a region of convergence, if there is a region for convergence, then the transform will exist. Otherwise, it doesn't exist. Now we will see that what is meant by region of convergence, ROC, ROC of Z transform, ROC of Z transform. What is this ROC is nothing but, what is this ROC? It is the values of small r. What is in the small r? It is the what is in the small r? Magnitude of Z. Small r, or we can say radius of the circle. I will tell you how to draw the Z plane and all. ROC of Z transform. Transform existence condition of Z transform is, what is the existence condition? Summation n equal to minus infinity to infinity modulus of x of n r power minus n should be less than infinity. It should be less than infinity. It should be less than infinity. It should be finite. So what is meant by ROC? ROC, region of convergence, is nothing but it is a set of values of small r. It is a set of values of r for which Z transform will exist. For which Z transform will exist. So if r value is different, or we can say if you consider the another value of r, Z transform won't exist. I will tell you when Z transform will exist, when Z transform doesn't exist. So what is my ROC? ROC is nothing but it is a set of values of R. It is a values of R. R equal to 1. R is nothing but radius of the circle. I will tell you. So it is a set of values of R for which Z transform will exist. Now how to draw the Z plane? How to draw the Z plane? Here Z is equals to R into e power j omega, where R is nothing but radius of the circle, radius of the circle, and omega is the phase angle. This is the Z plane. This is the Z plane. Now you can, this is the origin point. Here is the origin. You can draw the different radius values of with a circle with a different radius. Now let me draw one circle here. This is one circle with the radius. Let us take r equal to some 1. Now one more circle I am drawing. Let us take r equal to 2, r equal to 3. So like that we need to draw the circles. So basically this Z plane consists a circles with which is equivalent to magnitude. What is meant by r? R is the magnitude of Z. So first we need to draw the circles. Then how to represent this phase angle? Phase angle we will represent with, here is the 0 degrees. This is plus 90. This is plus 180. This is plus 270. Phase angle direction. Sir, if I go in the reverse direction, what I will get? This will be minus 90. This will be plus 90 and this will be minus 90. So now, for example, if someone asks you to draw z is equals to some 2 into e to the power of j pi by 4. If someone asked how to represent this 2 into e power j pi by 4, You need to select that. First you need to see that what is the radius of the circle. What is the radius of the circle? 2. You need to see that where is the radius of the circle. 2 is here. This is the radius of the circle. So this circle is there. This is the radius of the circle, r equal to 2. Now what is the phase angle? Pi by 4. Pi by 4 is nothing but 45 degrees. So 0 to 90, in between, exactly middle, you will get, this is the point. This is the point. Let me take, this is 2 e power j pi by 4. So I will draw one line for your understanding. So this is the representation of the point. No need to write the 2 e power j omega j pi by 4 like here. No need to write here. This is the point where where what is the point? Radius is 2 and the angle is 45 degrees. Angle is 45 degrees, or we can say pi by 4. Is it clear, everyone? So once again I will go back. Now, Z transform, how we will represent x of n? Z transform is x of z, where x of z is equal to summation n equal to minus infinity to infinity x of n z power minus n, where z is the r e power j omega, that also called as polar form. Now, magnitude of z is r, phase angle of z is omega. Then existence condition is, what is the existence condition? Summation n equal to minus infinity to infinity x of z r power minus n. So you need to select that suitable values of r to find the z transform. So if r value is other than the region of convergence, then z transform doesn't exist. So this r value plays a major role. That's what that we will call it as region of convergence. So, what is in the region of convergence? It is a set of values of R. It is a set of values of R for which Z transform will exist. Now, Z plane. How to draw the Z plane? Z is equal to R into e power j omega. So, I can say that this is the magnitude circle. This is magnitude circle. And what about face here? It is a face line. I'm drawing one line from the origin. I'm drawing one line up to here. You can see here. This is the phasor line. And magnitude is like a, we need to represent like a circle, and the angle we need to represent like a line. Is it clear, everyone? Next one, next one, pole and zeros. Pole and zeros of x of z. What is meant by pole and what is meant by zero? As of now, you try to understand this. X of z is equals to any transfer function. We can write it as numerator polynomial. Numerator polynomial n of z by denominator polynomial. You can say that numerator polynomial. It may consist n number of terms by denominator polynomial. Numerator polynomial by denominator polynomial. Now, if I want the pole value, I need to make denominator polynomial should be, I need to make it 0. Denominator polynomial I need to make 0. What is this pole? Is nothing but roots of the equation. Roots of the equation. I need to make denominator should be 0. How we will represent the pole? It is represent with cross. This is the cross representation with pole. Now, if denominator is 0, what will be your x of z? If denominator is 0, what will be your x of z?
Infinity.
X of z will be infinity. That means we need to avoid the pole, avoid the pole whenever you are considering region of convergence. You are considering the ROC, you need to avoid the pole, because at pole, means denominator will become 0. So at that time, what is the x of z? It is becoming infinity. That means your region of convergence doesn't contain the pole. You can write one note here. You can write one note. Region of convergence doesn't contain doesn't contain poles. Doesn't contain poles. Next. So denominator point we understand. Now what is the, like, zeros? Zeros are nothing but numerator polynomial. I will make it 0. If numerator polynomial, if I make it 0, that from that we can calculate the zeros. The representation is circle. Small o. Circle means not big circle. It's like a small, simple o. So now n of z equal to 0. What will be your x of z will become? If numerator polynomial is 0, your x of z will become 0. That means you can write one note here. You can write one note. ROC may contain zeros. If it is because it is less than infinity, no, x of z should be less than infinity. That is the z transform existence condition. So ROC may contain zeros, but ROC doesn't contain poles, because this x of z is going to infinity. So what is the existence condition for z transform? That mod x of z, this is mod x of z. Mod x of z should be less than infinity. Mod x of z should be less than infinity. So this condition it needs to satisfy. Then only Z transform will exist. Now, how to map the poles and zeros? I will write it here. Mapping of poles and zeros onto the Z plane. How to map the poles and zeros onto the Z plane? Now, let us take x of z is equals to, I will take simple one function, z plus 2 divided by z square plus 3. Z plus 2 divided by z square plus 3. Now, what is meant by zeros? Zeros is nothing but, I'll make the numerator term should be 0. What is the numerator term? Z plus 2 equal to 0. What is the z value now? -2. Now, what is the 0? 0 is -2. 0 is -2. How to represent this in polar form? I know what is the magnitude. Magnitude is 2. What is the phase angle here? Phase angle is minus. Minus means -1 is nothing but j square. 1j is 90 degrees. J square is 180 degrees. J is nothing but 90 degrees. J square is nothing but 180 degrees. Now -2 is there. You can draw here 2 at an angle 180 degrees. Is it clear, everyone? Is it clear, right? Now, first I will draw one circle here. First I will draw Z plane. This is the Z plane. Here is the Z plane. What is the radius of the circle? The radius of the circle is 2. The radius of the circle is, let me take here is the radius of the circle is 2. Radius of the circle is 2. Now phase angle is 180 degrees. This is 0. This is 90. This is 0. This is 90. And here is the 180 degrees. Now where is the 0 is there? Here is the 0 at 180 degrees. Here is the 0. Is it clear everyone? 2 at an angle 180 degrees. See here, this is the 2 magnitude at an angle 180 degrees. At an angle 180 degrees. So we calculated the zeros. Now, what is the pole over there? If I want to calculate the poles, what I need to do? Make the denominator polynomial should be 0. Z square plus 3 equal to 0. Now, what is Z square is equals to? Minus 3. What is Z is nothing but plus or minus root 3 times of J. Plus or minus root 3 times of J. How many poles are there? Pole 1. Or we can say Z1. What is that pole 1? Root 3 times of J. What is pole 2? Minus root 3 times of J. Now, I want to represent in terms of magnitude and phase angle. J is there. What is the phase angle will become? Root 3 at an angle 90 degrees. What is this minus root 3 J is nothing but my root 3 at an angle minus J is nothing but minus 90 degrees. Minus J is nothing but minus 90 degrees. Now, what I need to do, what is the magnitude of the circle? Root 3. Root 3 is nothing but 1.732. Root 3 is nothing but 1.732. I need to draw one circle. So let me draw one circle with radius of 1.732. This is the root 3 circle. Root 3 circle. What is the angle? What is the magnitude given? Root 3 at 90 degrees. So this is the on this circle. You need to identify the poles. What is the pole? Root 3 at 90 degrees. So 90 degrees is here. Representation with cross mark. One more pole is root 3 at minus 90. So this is the one more pole. Is it clear everyone? Any doubt in this pole and 0 how to map that? Any doubt in this? All of you? Now, now we will see that how to find the Z transform, Z transform and ROC of standard signals. We'll consider the standard signal and we will find what is the Z transform and ROC of the given signals. Now, two signals I will consider. One is x of n is equals to alpha power n into u of n. Alpha power n into u of n. Second one, x of n is equals to minus alpha power n u of minus n minus 1. So these two are the standard signals in Z transform. Standard signals in Z transform. Now we need to find the solution for these two problems. So the first one is, I will write it here. X of n is equals to alpha power n into u of n. X of n equal to alpha power n into u of n. So now x of n Z transform. What is the Z transform of x of n? X of z. X of n Z transform is x of z. What is this x of z is nothing but x of z is nothing but summation n equal to minus infinity to infinity x of n z power minus n. X of n z power minus n. Now summation n equal to minus infinity to infinity. What is this x of n? Alpha power n into u of n into z power minus n. Now u of n is there, your limits will become summation summation n equal to 0 to infinity alpha power n z power minus n. Now I will write as summation n equal to 0 to infinity alpha into z power minus 1 whole power n. Now again you recall the formula. What is the formula? Summation n equal to 0 to infinity alpha power n is 1 by 1 minus alpha. Use this formula. Use this formula. So what you will get it here, if you use that, you will get 1 by 1 minus alpha into z inverse. 1 by 1 minus alpha into z inverse. So here 1 by 1 minus alpha into z inverse is nothing but alpha by z. If you simplify this, 1 divided by z minus alpha by z, so it will go to the numerator z divided by z minus alpha. So either you can leave up to here or you can go up to here, no problem. Now we found that what is the what is the jet transform, but we need to find what is the ROC. Here alpha should be less than 1. This one also very important here. This is the ROC here. Alpha should be less than 1. So now what is the alpha here? Alpha into z inverse, it should be less than 1. That means mod alpha by z, it should be less than 1. So mod alpha should be less than mod z. Otherwise you can write mod z should be greater than mod alpha. Mod z should be greater than mod alpha. So this is the ROC. This is very, 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 very important. What is the jet transform and ROC for the given signal x of n is equals to alpha power n u of n? What is the ROC? Z should be greater than alpha. Now we will write one problem. X of n is equals to 1 by 2 whole power n u of n. Find the jet transform and ROC. Find the jet transform and ROC. Now same whatever derivation we done, same thing we need to do, write it here. Solution x of n jet transform is x of z. 1 second. So x of n z transform is x of z. Now what is the z transform for this? X of z is equals to summation n equal to minus infinity to infinity x of n z power minus n. Summation n equal to minus infinity to infinity. What is x of n? 1 by 2 whole power n into u of n z power minus n. So whenever you are having the u of n, your limit will become summation n equal to 0 to infinity 1 by 2 whole power n into z power minus n. Summation n equal to 0 to infinity 1 by 2 into z power minus 1 whole power n. Now we remember that we need to remember that formula summation n equal to 0 to infinity alpha power n is equals to 1 by 1 minus alpha. Mod alpha should be less than 1. Mod alpha always should be less than 1. So now here this will become x of z is equals to 1 divided by 1 minus 1 by 2 into z inverse. So 1 by 2 into z inverse, it should be always less than 1. This is the ROC. Here is the ROC. Now if I want to simplify this, 1 by 1 minus 1 by 2 into 1 by z. Z inverse is nothing but 1 by z. 1 by z. Now z only you take that side, it will become z by z minus 1 by 2 mod z. It should be greater than 1 by 2. Mod z should be greater than 1 by 2, or mod 1 by 2 you can take. Mod z greater than mod 1 by 2. So now how to represent this ROC? How to represent this ROC? Simple. Here is the z plane. Here is the z plane. This is the z plane. What is the magnitude of z? What is the magnitude of z? It is 1 by 2. It should be greater than 1 by 2. So first you draw 1 by 2 circle, radius of 1 by 2, radius of 1 by 2, because this is the pole, z minus 1 by 2. Right. So z value is always greater than 1 by 2. That means your region of convergence is outside of, sorry, outside of the z plane. Outside of this z equal to 1 by 2, you can see here. So this is what your region of convergence. It should not go inside. It should be outside of the circle. Now you see here, what is the u of n? U of n is right-sided signal. U of n is right-sided signal. What is the ROC in Z plane? What is the ROC in Z plane? ROC is outside of the circle, outside the circle, outside of the circle, out of the circle, or you can say outside of the circle, outside of circle. Now you see that u of n. So what is the z transform? Z by z minus 1 by 2. So now what is the ROC? Z is greater than 1 by 2. Sir, if I am considering one circle z equal to 1 by 3, whether z transform will exist? No. If you are considering inside of the circle any point, z transform doesn't exist, because what is the region of convergence? That is outside of the circle. That is outside of the circle. If the signal is right sided, if the signal is right sided, then your ROC is outside of the circle. So this is the first question. Coming to the, so from here I took x of n is equals to 1 by 2 whole power n into u of n. This problem also we solved. Now second one, x of n equal to minus alpha power n u of minus n minus 1. Second one, x of n is equals to minus alpha power n u of minus n minus 1. You see here, now what is x of n z transform? X of n z transform is x of z, where x of z is equals to summation n equal to minus infinity to infinity x of n z power minus n. What is x of n? X of n is summation n equal to minus infinity to infinity. What is x of n? Is nothing but minus alpha power n u of minus n minus 1. Now you can take minus outside, summation n equal to minus infinity to infinity into z power minus n, alpha power n u of minus n minus 1 z power minus n. So now what is meant by u of minus n minus 1 is nothing but it should be 1 for n minus 1 minus n minus 1 less than 0, sorry, greater than 0. If it is minus 1 minus n minus 1 greater than 0, it is 1. Minus n minus 1 less than 0, it is 0. Now minus n you send that side, it will become minus 1 greater than, minus n you send that side, this will become plus n. So 0 minus 1 greater than n. Now, if you rewrite this one in a correct way, n is less than minus 1, 0, n is greater than minus 1. So, what is the n is less than minus 1 is nothing but your limit will become minus summation n equal to minus infinity to minus 1. Your limit will become u of minus n minus 1 is nothing but your limit will become n equal to minus infinity to minus 1 alpha power n into z power minus n. Now minus summation n equal to minus infinity to minus 1 alpha into z power minus 1 whole power n. Oh, 1 second. Now if you look at here, what is the n limit? Minus infinity to minus 1. Minus infinity to minus 1. So what I will do here, I will consider let n is equals to minus m. Let n is equals to minus m. Then what is your x of z will become minus summation m equal to infinity to 1. M is nothing but infinity to 1 alpha power minus m z power m. Alpha power minus m z power m. Now minus summation m equal to infinity to 1 or 1 to infinity, both are same because it's addition. Already I told you 0 plus 1 plus 2 plus 3 is same as 3 plus 2 plus 1 plus 0. Both are same, right? So this is a summation. Summation, if you interchange the limits, no problem. So minus of m equal to 1 to infinity, you will get alpha power minus m into z power m. But I want one more term here. That's why minus of summation m equal to 0 to infinity alpha power minus m z power m. Okay, 1 second. This I will take from 1 only. Now what I will write it here. Here I'll take m outside. That means alpha power minus 1 z whole power m. So now alpha power minus 1 z whole power m. I will add 1, subtract 1. I will add 1, subtract 1. What I will get it here? Minus of summation. See, m equal to 0, if you substitute, what is the value you will get? Plus 1 only. That's what I will write. M equal to 0 to infinity alpha power minus 1 into z whole power m minus 1. This minus 1 you need to write it here. Minus of what is the value you will get it here? Alpha power minus 1 into z whole power m. Alpha power minus 1 z whole power m minus 1. What you will get it here? 1 by 1 minus alpha inverse into z minus 1. Now if I simplify this, what is your x of z will become? X of z is equals to minus of 1 by 1 minus alpha inverse into z minus 1, right? Now minus of 1, you take LCM, 1 minus alpha inverse into z, you take LCM. What you will get? 1 minus of 1 minus alpha inverse into z. Now is equals to minus of 1 minus 1 plus alpha inverse into z divided by 1 minus alpha inverse into z. So now this 1 minus 1 it will be cancelled. You will get minus of alpha inverse into z divided by 1 minus alpha inverse into z. Now if you multiply with minus here, what you will get? Alpha inverse into z divided by, you can take it as alpha inverse z minus 1. Minus, if you multiply, this will become 1 minus alpha inverse z will become alpha inverse z minus 1. Now carefully, z by alpha whole divided by z by alpha minus 1. You can write it as z by alpha divided by z minus alpha by alpha. Now alpha cancel. What is the Z transform here? Z by Z minus alpha. You see this alpha power n u of n is Z by Z minus alpha. But here alpha power n u of minus n minus 1 is Z by Z minus alpha. But what is the difference? The difference is ROC. What is the ROC here? What is the ROC here? We need to write it as the ROC will become alpha inverse Z less than 1. So here I will write it here. Alpha inverse Z, it should be less than 1. It should be less than 1. Because here this one we done right. 1 by 1 minus alpha inverse Z. Alpha inverse Z should be less than 1. Now alpha inverse Z should be less than 1. You can write it as Z by alpha should be less than 1. Mod Z by mod alpha should be less than 1. Mod Z should be less than mod alpha. Mod Z should be less than mod alpha. What is the ROC here? What is the ROC? Mod Z should be less than mod alpha. So in the previous case, what we got? Mod Z is greater than mod alpha. So when the right-sided signal, the Z is greater than alpha. For left-sided signal, minus n. For left-sided signal, mod Z is less than alpha. So now let us take, this is the Z plane. Let us assume here is the alpha. Here is the Z equal to alpha. Now, what is your ROC? ROC is less than alpha. That means inside of the circle. That means inside of the circle. You remember this one. So, if the signal is right sided, outer side of the ROC is outside of the circle. If the signal is left sided, you can see that the Z should be less than alpha. Less than means it should be smaller than alpha. So now you can write one note here. You can write one note here for left sided signals. For left sided signal, what is the ROC? ROC is inside the circle. Inside the circle. For right sided signal, the ROC is outside the signal, I mean circle. For left sided, the signal, the ROC is inside the circle. Is everyone clear about this? So this is the standard for jet transform of the standard signals. Now we will consider one example. We'll consider one example. You only need to tell now what is the ROC for the given signal. Let me take so directly I am writing here. Now this is for understanding I am writing. So now what is the jet transform for minus 1 by 2? Let us take x of n is equals to minus 1 by 2 whole, okay, minus of 1 by 2 whole power n into, 1 second. So second question example I am writing x of n is equals to minus 1 by 2 whole power n u of minus n minus 1. What is the jet transform? So anyway you need to follow the procedure as for given here. This procedure, in the place of alpha you need to write 1 by 2 whole power n. That everything you need to write. But here directly I am writing from the standard standard signal alpha power n minus of alpha power n u of minus n minus 1 jet transform is What is Z transform? Z by Z minus alpha. But ROC is mod Z less than mod alpha. Mod Z is less than mod alpha. Now similarly here minus 1 by 2 whole power n u of minus n minus 1. What is the Z transform? Z by Z minus 1 by 2. Mod Z is less than mod 1 by 2. Mod Z is less than mod 1 by 2. Is it clear, everyone? If the signal is left sided, if the signal is left sided, it should be, what is the ROC? So first you draw the 1 by 2, the radius should be 1 by 2. This is the Z equal to 1 by 2. The ROC is inside of the circle. It should be less than, Z should be less than 1 by 2. Less than 1 by 2 means inside of the circle. Greater than 1 by 2 means outside the circle. So this is the ROC for the given signal. But in exam, if they given this one, you need to write the procedure. What is the procedure? X of n, Z transform is x of z, where x of z is equals to summation n equal to minus infinity to infinity x of n z power minus n. What is x of n? Summation n equal to minus infinity to infinity. X of n is nothing but minus of 1 by 2 whole power n u of minus n minus 1 into z power minus n. So you need to write minus summation n equal to minus infinity to minus 1 by 2 whole power n into z power minus n. If you simplify this, simplify simplify this, what you will get? X of z is equals to z by z minus 1 by 2. And what is the ROC here? Z is less than 1 by 2. So this is the standard Fourier series.